Alright guys, I'm going to go really quick through this worksheet because it's a long worksheet and I don't want to make the video too long. It's not my worksheet, but this is a nuclear chemistry worksheet. So we know that alpha looks like something like that, usually drawn a little better. Beta looks like this with the long tail, gamma like this, and then a neutron, we should all know what a neutron is, right? Okay. Or just the N by itself. Um, let's see. So this would be a neutron. This would be beta decay, right? This would be alpha. The 4 2 helium, remember it's just the nucleus. And then this right here is going to be our gamma. Alright. So those are the common symbols associated with these. Remember there's also the positron, which looks like this. Beta plus. You won't see this in this worksheet though. Okay. So, nuclear decay with no mass and charge, that is going to be gamma, right? Because it's 0, 0. An electron is 0, -1 e, right? That's the same thing as a beta particle. They're the same thing. This is interchangeable. You guys will most likely just write it like this, though. The least penetrating, that's going to be alpha. Most damaging to the human body, that is gamma for sure. Gamma is very, very bad for you. You don't want to be exposed to that. Can be stopped by skin or paper. That's going to be alpha as well. Stopped by aluminum, that's going to be your beta. Your beta decay is going to be stopped by aluminum. Alright, so we're going to jump right into this. Remember what he said, the chart, everything has to add up to be the same, right? So 42 because not 40. Oh, great. So we'll erase this whole area so I can write in it. Okay, 42. These have to add up to be the same, so 18. And that is going to be not what I have written down. Oh, I'm sorry. That's because I messed up. It's not going to be 18, right? It's going to be 20 because 20 plus -1 equals 19. Alright, so for the next one, this is going to be 235, right? 235 plus 4 is 239. This will be 92 down here. And that's going to be U. You're gonna check out this number right here, and you're just gonna look it up because nobody's gonna have all this memorized. So since this is the same, it had to have emitted a gamma ray, right? Nothing changed. All right, number 14. So what do I need to add to get to 235? That's gonna be 4. 90 plus what is 92? That's 2. That's going to be our alpha decay. So helium. The next one. All right. So what plus 4 is 6? That's 2. What plus 2 is 3? That's 1. We looked that up. And that's something you should have memorized. That's hydrogen. All right. So 142 plus 91 plus 3 ones, right? That's going to add up to be 236, 56 plus 36 plus 3 times 0 is going to add up to be 92. You want to stop and do the algebra on this just to double check me. I'm not perfect. You guys know that. I'm far from that. Alright, so we're going to use this table right here to answer these two questions. When we're looking at the decay here, we have our alpha part. How many alpha particles are produced as one atom of uranium-238 decays to an atom of lead-206? So, in counting, we're going to count the A's. There's 8 of them. All right, now let's change color real quick and go to the betas. All right, so how many betas? All right. And that looks like 6. Simple enough, right? That part should be pretty easy. All right, so I flew through the first part actually pretty quick. Let's make that disappear. Let's go to the second part. Do I have the whole thing on here? I do. Awesome. Okay. Write an equation showing when this element, protactinium, 229, goes through 2 alpha decays, and at the end, francium 221 is formed. So that's a good check right there, if you see that. Let's start at the beginning. Oh my god. Here we go. Okay, 229. If we look that up, it's going to be 91, I believe, PA. All right, so first alpha decay. We know we're going to have 42HE, because that's the definition of alpha decay. Sorry about my handwriting. It's so hard to write on these sometimes, especially when I'm on a slanted surface, so everything's going to look a little slanted. So 229 minus 4 will give us 225. 91 minus 2 should give us 89. And that's going to be, when you look it up, AC. So we got to switch colors here. So we're going to look at the next decay. These have to be done in order. You can't just keep going. You have to go, okay, this one with this decay. Now we have a new element. Let's put it under another decay. So we've done one alpha decay. We're going to do another now. 42HE. That's the definition of alpha decay. And that 225 minus 4 is going to be 221. And 89 minus 2 is going to be 87. When we look that up, that ends up being FR or francium. And we wanted francium 221. 221, we got it right there. So we're good to go on that. Next. This one's a long one. Okay. A nuclear equation for the decay of PO210 when it undergoes 2 alpha decays, followed by a beta decay, followed by another alpha decay. Let's just take a second to let that all sink in while we write the first part. All right. So we're going to do our first alpha decay for 2HE. 210 minus 4 is 206, and then 82, because 84 minus 2. And when we look at that element, we are going to see, it's going to be lead, actually. Lead, yep, lead 206. All right, so again, color change, 206, 82 PB. That's going to go to through another alpha decay, right? Second alpha decay, 42HE plus this minus this will give us 202. This minus this gives us 80. We look up, see which one is element 80. What do you know? Mercury. Next. All right, 202, 80 Hg. This is going to undergo beta decay, right? You guys remember the definition of that? It's going to be 0, -1 E. Plus, now remember, beta decay is when a neutron releases an electron but turns into a proton. Just take a second to think about that. But 202 minus 0, 202. 80 minus -1 is going to be 81. Okay, and that's going to be that. And then another alpha decay. Sometimes these can be a little longer. So 202, 81, another alpha, 42He, plus, okay, 202 minus 4 is going to give us 198. And 81 minus 2, that should be what, 79? Can I math? Yes. So check it out. If we had a piece of this and it underdid all those decays, we'll have some gold. Radioactive gold, but gold. All right. So we're going to check out for this question. The decay chain or series of uranium-238 is shown in the following figure. What is the final product of the decay series? So we have our mass numbers right here. This is going to be our final product, right? So it's at 206. So our final product is going to be 206 Pb, or lead 206. Okay. We all know, or we know that lead is always going to have 82 protons, right? Okay, so using this, we're going to go through and list all of the decays. So this first one right here, it went from 238 to 234. It's going to be an alpha decay. Sorry for my crummy handwriting. So this one's alpha. So you're just moving along here. You're if you can see, you're gaining a proton. So that means that's a beta decay, right? And then look, it happens again. You gain another proton. Another beta decay. All right. Then right here, look how far down you go. You go from 234 down to what? 230. That has to be an alpha decay. That's 4, loss of 4 in your mass. And it happens again, right? You lose another 4. So there's another alpha. Oops, sorry. Another alpha decay. After that, so we went alpha, beta, beta, alpha, alpha, another alpha. And all of these are going to be alpha decays. So we should have a total of 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. So now, look, it's going back this way again, and it's jumping by 1. Those are going to be more beta decays. Right? You could tell because, look, it's losing a neutron. But that neutron's turning into a proton, so there's no loss of mass across here. But there is gain of protons. So we have our first beta decay, and then another beta decay followed right after. You can see it. 1 beta decay, 2 beta decays. We lose another 4, so that's an alpha decay. And then again, following the same pattern, beta, beta. So what happens here? Let's see, 210, 206, that's going to be another alpha decay. So, like I said, sorry about the handwriting. It looks really bad, but so remember, you just need to know your definitions on this. Alright, so this is the more challenging part. We're going to start with this, okay? I'm sorry, we're gonna start with the 232, I'm sorry. So this is not right. That should say 232. Okay. So 232, TH for thorium, and it's going to be 90 when you look it up. Undergoing an alpha decay, 42He, plus that minus that is going to give us 88. And that minus that is going to give us 228. And that's going to be there. Okay, so we're gonna, as we go, we're gonna just continue with the ending result, because it's saying it's undergoing decay until it reaches stable. Okay, so 228, 88, Ra, beta decay, 0, -1, E, so 228, 89, and when we look that one up, it's going to be AC. And I'm just going to keep changing colors to 28, 89 AC. Let's go in another beta, -1E, plus 228, 90, and 90 is going to be, okay. So this undergoes color changes. Alpha decay, 42HE, plus that minus 4 is going to give us 224. That minus 2 is going to give us, oh my god, how to math, 88. Yep, and we're at RA. Now you notice how it went back to RA again, but look at the mass numbers, 228, 224. It's trying to lose mass. Until it gets, stable. Okay, so new color. Another alpha decay, 42HE, plus, and that minus that, 220, that minus that, 86, and look that up, it's going to be RN. Let's see how bad it looks if I change the size a little bit and get rid of some of the shaky. All right, 220, 86, RN. We're going one more alpha. Like I said, it's trying to lose mass so it can be more stable. It's getting rid of the neutrons. So 220 minus 4 is what? 216. 82 or 86 minus 2 is 84. All right. So 216, 84. Yep, that's hard to read. PO. It's going a little more alpha decay. By the end of this worksheet, you guys should be really good at writing these, because look how much we're having to write here. Okay, 216 minus 4, that's going to be what, 212? Can I math? Yes, I can math. And then 82, right? 84 minus 2, 82. And we are at lead. And a new color, 212, 82 PB. Once it undergoes that beta decay, that's, remember, beta, 0, -1 E for electron. Mass is going to stay the same. It's going to bring us up to 83, which is oh, you know what? I think I found a mistake. Oh, 83. So, bear with me for 1 second. I know this video is already long. 83 is going to be BI. Okay, so we'll undergo another one. 212, 83 BI. another beta, 0, -1e, 212, um, 84, which is going to put us at PO. Oh, sorry, I didn't change colors last time, guys. 212, 84, PO under alpha decay, 42HE. 212 minus 4 is, God, I can't math, 208. And then that minus that is going to be 82, which is PB. And for the beta decay, we're going to go 208, didn't change colors, that's fine. Beta decay, 0, -1, E plus 208, 83, which is back to bismuth. Now, since that's the end of our list here, it says circle the final stable isotope. So let's go ahead and do that. Doesn't that sound great? This is going to be it, right? It doesn't show any more decays. So I'll write it over here a little more clearly. That's going to be 20883BI. I really, really hope this helps, guys. I know I just flew through everything, but let's hope it helps.